W equals mg is a special, simplified case for working out the forces due to gravity near to the surface of a planet, for instance. But if you move further away from the planet, you've either got to start changing the value of g, and you've got to know, well, how much would it change by? And basically underlying the W equals mg equation is Newton's law of gravitation. And what was so special about Newton's work, one of the reasons is it's kind of stuck as one of the most famous scientists, was that he was able to link the motion of the apple that fell on his head with the motion of the planets, and show that in actual fact we're all governed by the same law that he came up with here. And he reckoned that the magnitude of the force depended on the mass of the particles involved and the distance between the two particles. And he came up with this general equation for gravitational force. We had a constant g, known as the universal constant, and the two masses involved, and then the separation, which is usually called r, maybe linked to the radius of planets, but it's divided by r squared. Now g is incredibly small, 10 to the minus 11, which means that for small masses on Earth you're not really going to notice these gravitational forces, but they do actually exist between any two masses. It's just that when you've got large planets nearby, then they're going to dominate the gravitational forces, and we become more aware of them. So you know, the mass of the Earth is 10 to 24 kilograms, and you multiply that by 10 to the minus 11, you're going to get more noticeable values. So here there's a worked example just showing you if you had a boy and a girl, if their masses are separated by 3 meters, the force would be tiny fractions of a Newton. And even that's not accurate, because it does assume the basic idea of spherical masses, that all of the mass of an object can be considered as being concentrated at its centre. Now that's true for roughly spherical objects, but not really for kind of more irregularly shaped objects such as people.